Good morning, everybody. Thank you, David and Richard, for that introduction. We're really excited to be here today to showcase the work that we've done over the past few months and share our vision with you for this space. Next slide, please. Before we take a look at this project in more detail, I want to give you a short intro into Mind Foundry and introduce some of my colleagues that you'll be hearing from later on. Mind Foundry is an Oxford University company founded to apply powerful machine learning technologies to real-world problems with a focus on human-centric and responsible technologies. I'm Jo, Mind Foundry's product strategist, and I'm joined here by my colleague, Dr. Alessandra Tosi, who is our lead on this project and will introduce you to our solution. Dr. Rob Bell, who's heading up our technical team, and Richard Appletree, our commercial lead, are also on hand to answer any of the questions that you might have after the presentation. Next slide, please. I think it's important to mention at this stage that we are very grateful to all of the contacts that we've worked with since the start of this project. This energy distribution and EV space is incredibly complex. We've learned about the power dynamics at play, the different motivations behind decisioning, the fractured data availability, both open source and proprietary, and the long-term vision of players in this space. Our team has spent a long time working with our partners at Oxfordshire County Council, gaining a deep insight into their motivations, their user journeys, and their current and future pain points. Next slide, please. Before Alessandra takes you behind the scenes on this project, there are some key benefits from Mind Foundry's solution that I want to highlight here. It's not a secret that one of the major challenges of this solution is the display and interrogation of fragmented or disparate geospatial data. We knew that we had to deliver a powerful user-friendly solution, but we've also gone beyond. We needed to understand crucially what decisions are being asked of this data. For example, in this case, where to place a new charge point, and to quantify the impact of those decisions. So we've created a tool that can both allow you to interrogate the data that's available to you and strategize from it, to assess the impact of your decision, and to do so in a responsible and transparent way, understanding the limitations of the data that you have at your disposal today and the data that you would require to make a better decision tomorrow. So throughout the course of this project, we've focused on several different user personas. There are two that we'd like to touch on today, and these are the EV strategy teams in local authorities and the location teams for charge point operators. Both of these intended user groups have different strategies, set themselves different objectives, and have to collaborate in planning decisions. It's with these users in mind that we've developed the tool that you're about to see. So without further ado, I'm going to pass to my colleague Alessandra to take you on a deep dive of Mind Foundry's solution.
Thanks, Jo. I'll take it from here and present the work we have done for the alpha prototype in the past 3 months. We have built a prototype of an innovative energy-focused geospatial software system that will facilitate the transformation of the energy sector in the pursuit of the UK's ambitious goal to be net zero by 2050. We have utilized a variety of cross-sectoral geospatial data to help the energy sector to be more quantitative and more targeted in its planning and its prioritizing of resources. So we have specifically focused on the challenge of the energy and transport sector to improve the infrastructure that can enable electric vehicle uptake in the country. So that was our focus. Our tool is not simply a data visualization tool and a data modeling platform, but it's also a tool that provides the unique ability to strategize on multi-sectoral data by using data-driven, explainable, and actionable insights. Sorry. I'm going back to the slide. I'm sorry. We have developed a web application that can be used to evaluate and plan a range of different strategies in the context of electric vehicle charging infrastructure, as I mentioned. So the proposed system that we have built enables users to visualize overlays of multivariate spatially and temporally varying data to combine data from different sources and to encode constraints of this data But we also have embedded machine learning model capabilities into the platform, particularly to predict trends and correlations and infer across areas of sparse or missing data collection. We do know that some of the data available have this property of having missing data and not being complete. And we also provide models for the effect of changes in the system, such as varying supply and demand or infrastructure in the context of EV, electric vehicle infrastructure. So the system enables data-driven strategy implementation that allows for simulation, testing, and optimization of different strategies that align with longer short-term priorities of the users who are using the system. An example use case we've been focusing on in particular is the optimal placement of electric vehicle chargers, such as, or infrastructure in general, such as charging hubs, off-street chargers, lamppost chargers, galley solutions, but also ultra rapid chargers or car clubs, how to handle that type of infrastructure. So a wide range of solutions in this space. A little deep dive on our AI capabilities. We have used AI to transform data into actionable insights in solving problems such as identify suitability of on-street charge point solution, starting from OS open map data as an example. And as you see, it's displayed in the two images here, where we do have in red, the roads that are predicted as lacking off-street parking, and in green, roads that are predicted as having off-street parking. This is quite useful for the planners to know because they can immediately identify where the issues are in relation to off-street parking availability. Other examples of modeling we have done are modeling point access data and also identify charge point deployment inequality. I will now share my screen and show a live demonstration for our alpha prototype. So here is our alpha prototype. You should be able to see my screen. I'd like to show you this live demonstration, and I will present today two workflows that you can see here on the left, the data exploration workflow and the solution explorer. Let's start with the data explorer and describe a little bit what is it. This platform that we have built works on the full UK national territory you see on the map. Here today I will focus on the Oxfordshire area because, as my colleague Joe mentioned, we have been working very closely with Oxfordshire County Council, with our partner, and is supporting the project as well. So we demonstrate our outcomes in this area. We have integrated multiple data sources such as demographics, deprivation index, EV charger location. I can show some of them. For example, we are seeing displayed existing EV charge point, but you can see the deprivation index. So this is some information that's very useful for the council, or the availability of on-street parking that I have highlighted just in the previous slides, or other data about, for example, vehicle crime that might be useful if you do want to deploy infrastructure and you want to know what type of crime is, for example, happening in that area. So these are different type of data you can visualize as an overlay. The key features we have implemented are matching the user's requirement. This is very important. We have really worked with the users to understand their pain points and trying to match their requirements as much as possible. And things from the simple to the more complex things are really built on the user requirements, such as, for example, the ability to add custom data that is very important, being these open source or proprietary, easily exporting data and insights in different formats, and visualizing layer across different geographical areas, so not only a limited one. The extended user research that we have carried out in the past 3 months has highlighted the importance of communication between different stakeholders. This is really a key point we've been focusing on during the project. The importance of communication between different stakeholders and the negative effects of miscommunication in the development and the growth of the energy sector. This is a clear problem in the sector, and we have validated that our product addresses this problem, and we have built this data exploration workflow to this purpose. Um, in fact, given a wide range of multi-sectoral data, the user is able to visualize and analyze them to uncover EV and energy related issues specific to the geographic area. And we see on the left here, there are some issues highlighted of three types: access, infrastructure, and rollout. We can show them in the map. And what is this telling us? This is telling us that in the area we are focusing on, there are some problems we might want to address, problems of different sources. One example could be, for example, let's take a look at this access issue. Here we have an issue that says that this area does not currently have any access to on-street chargers, and this issue has been produced by analyzing this type of data displayed here. So the system is transparent and it exposes to the users which data have been used to identify the issue and produce this outcome, this recommendation. And in addition, it's suggesting possible solutions that are expressed here in this area. For example, you could explore the Gali solution and you would need to go to the Solution Explorer and try to use the Gali solution to solve these issues, so to try to provide access to the people living in this area. So that's one workflow that we have implemented. We can also highlight infrastructure issues about limited availability of power capacity, or also very important rollout issues. So highlighting where there is some rollout inequity issue. That's something that particularly local authorities really care about. Yeah. So in addition to this issue presentation, a full analysis and a data-driven report on how these issues impact the region can be produced and can be exported in a PDF format. This analysis really enhances and augments the data exploration workflow that I just presented. So the analysis can be viewed here. It's important to notice that as you can see, that this analysis provided has multiple views. You can see social view, charge point view, and custom KPIs. And I will explain a little bit this. These views show different information related to user-specific goals. An example is that the local authority, the user from local authority, might want to focus on the equity of infrastructure rollout rather than on the return of investment. Maybe a charge point operator, it's more focused on the finances, annual financials, and their priority might be more about the numbers and the usage of the charging column. So each user has their own strategies, and they can see and explore them with this tool. Let's move now to the other workflow I want to show you, the Solution Explorer here. So for this workflow, we are given a geographical location we can choose nationwide. And we want to tackle the problem of selecting a number of locations that are optimal to deploy EV charging point infrastructure. So let's say, for example, if I have a number of car parks in my local authority, a number of council-owned car parks, which are the best, which are the ones that I should prioritize today to build some EV infrastructure first with the highest impact today, and limited resources that I have. So this tool will help you to optimize this selection and provide some insights on how to perform this prioritization. The prioritization that we have built is data-driven, and is built upon customizable targets. It is important that these targets of the prioritization are customizable because, as I mentioned a moment ago in a previous workflow, each user has their own strategies, their own priority. For example, the Oxfordshire County Council we have been spoken to, they have defined their own Oxfordshire vehicle infrastructure strategy. It's a very wide strategy and they're trying to follow that, but other local authorities may have defined different strategy. In fact, we have spoken to some of those and they all had different, slightly different goal and targets. And if we look at the other users of the platform, the charge point operators and other stakeholders, they might have totally different targets or partially different targets. So it's really important that when one is defining the prioritization method here, it's customizable. And this is what we have done. Not only, it's also data driven. So you can integrate the data into the prioritization formula and method and have data driven outcomes computed by the system. So we can consider here the problem of deploying charging station into this council. These are council owned car parks. And this is a real use case we've been working on with Oxfordshire County Council. So you can load the data and you can see here are the car parks, and maybe you want to find today, you have budget to upgrade 10 locations, and the system is recommending you to upgrade these car parks. For example, it's telling you some statistics, some information about these car parks and what to do, and providing you this recommendation. But this is not enough. So you don't want just a recommendation. You want to understand why this recommendation has been provided. And we have been working on this prioritization directly with our project partners, benchmarking the prioritization strategy against the prioritization strategy that we're already using in-house. And we have extended to a data-driven and customizable approach. So our user can easily add prioritization method and enhance it with data available on the platform. They can also add their own data and improve it even more. Another innovation to complete this workflow that we have implemented is that we allow the user to check the impact of this strategy, this outcome. So the impact of picking these 10 parking spots in comparison with other parking spots. So you can visualize this here. And this is very important because the impact allows the users to check the impact of a strategy against different targets. So on one side, you can have return of investment, equity of rollout at the same time, and compare those. We found that this feature really addresses one of the main pain points of our users, which is the difficulty in communicating between different stakeholders, but also the difficulty of finding transparency between different stakeholders. So for example, if one charge point operator is applying for a tender and they say, oh, these are really the best car park, maybe the local authority in that area does not really understand what's their reasoning behind this prioritization. And this tool will really help that communication to happen and that information to be uncovered in a completely transparent way. So that's, we think, is really powerful. This impact analysis, moreover, can be exported and used to address impact strategy. You can share it with other stakeholders, and it's also important that you can use it to compare two different strategies, because maybe you can produce the impact of one strategy and then change it a little bit and make comparison, and this is really powerful. And with this, I go back to the slides. And I just wanted to conclude with the wrap up with really a quick thought on our wider vision for the future as a company, to put this project in the context of what we want to achieve as a company. So we know that the UK aims to reach net zero carbon emission by 2050. This is really ambitious target, and the energy and transport sector need to undertake a transformation in order to achieve this goal, and data-driven approaches to the problem will play a critical role. That's a fact. So Mind Foundry collaborative solution will enable stakeholders to transform their decisioning and modeling capabilities to meet this challenge. So that's our goal. Thank you for listening. There is our contact details here. I'm really happy to take any questions. So please.
Brilliant. Thank you very
ask.
much. That was a really great presentation and nice to have a live demo as well. So thanks for that. So we do have a few questions coming through. I guess to kick off, so as part of the Modernising Energy Data Applications project, this was designed to integrate with the open energy solution being developed. Could you just describe what interaction you had with the open energy project and what, if you were able to benefit from some of the development they're making already?
Definitely. So we did put this as a priority at the beginning of the design phase that we have embraced at the beginning of the project. And we did build up our architecture to meet the goals required for by the open energy progress. And I will pass this question to my colleague, Rob Bell, who is our tech lead and has really worked hard on this integration. So Rob.
Yes, it's a great question actually, and I think it's something that was very much in the back of our mind when we were developing this project, that the energy data sector is very new, and we expect that new data will be added over time. So our design is flexibility at the heart of it, to say let's be able to incorporate new data when it becomes available, and the way that we're proposing that we will do that is by actually having the ability to search the Icebreaker One platform for new data and to be able to incorporate it directly into the platform. So really about making it easier to add more data and make it so that we can use that data. Does that answer your question?
Yeah, that's great, thank you. So you've picked up the architectural design from Icebreaker already, and then you've also got the flexibility to integrate new data sets as you go forward.
Yeah, absolutely.
Fantastic. Brilliant. So we've had another question. So obviously your work is focused on the Oxford area, which is one of the more advanced local authorities in terms of decarbonisation and EV adoption. Have you, in terms of your potential scale up, have you had any interaction with other local authorities that are perhaps a little bit earlier in their journey?
Yes, we did. And actually, we did interact with quite a range of local authorities. We purposely looked for local authorities at different stages of their journey in their deployment of EV infrastructure. And also we purposely looked at local authority with the different geographical situation, for example, very wide rural areas, etc., that pose big challenges to the deployment of EV infrastructure. So we have what we have the outcome after doing this research and addressing and trying to understand their pain points is that the initial stage of the issue identification is really a key stage that the local authorities need to do at the very early stage of their EV journey or the EV infrastructure journey, and trying to understand which are the main blockers in their area, if it's infrastructure in terms of power capacity, if it's infrastructure in terms of wider rural areas and sparse population. All this is something that the platform can highlight, and we are also working in the next stages on use cases that are addressing some of these problems, such as, for example, as I mentioned, how do you deploy infrastructure in rural areas, which is a big challenge for some local authorities, because obviously, as one might know, the return of investment in those rural charging stations is definitely lower. And the local authorities need to combine limited funding with the benefits for the population. So we are also addressing these challenges, and we think that the impact analysis that we can provide it's really trying to uncover what are the local benefits for local authorities that are at different stages of their journey.
Great, thank you. Kind of related to that question, are you clear what data sets you'll need to be impactful at a national level? And what difficulties do you see in securing access to these data sets?
Yes, we do. We do see that some of the data might not be available at national level, although we are positive that some data will come up in the future. Many of the data we have used are accessible at national level and are open source. And some of the data that are proprietary have been provided by our project partners, and some other local authorities and project partners we have been discussing with are gathering those data and are in the process of digitalizing the data that are not available. So we have seen huge progress in this, although we know that there is still a lot of work to do. So most of the workflows will work, but some of them might need some time to wait for the digitalization to happen fully.
Brilliant, thank you. So your solution's focused on the EV part of the net zero strategy. Do you think it would be possible to expand your application or your approach to other components, so battery storage, hydrogen, etc.? And how easy do you think this would be?
We don't have this in the short-term roadmap in the next 6 to 9 months, but we have this. We have thought about this as a wider project, also in combination with other projects we are running as a company. So yes, we do have internal capabilities to address those problems through modeling, particularly through time series forecasting. Some of these problems really requires a strong capabilities of predicting trends and also some time series forecasting capability. We have thought about integrating that, but honestly, we haven't investigated in detail what type of data would be available to fully solve battery storage and hydrogen solution. We have been focusing more on the side of the distribution. So that other type of use cases we have explored to help distribution networks to manage capacity, and potentially something that we also want to investigate, but was not mentioned here, was not the main focus of the first 3 months phase, is, for example, how to use EV batteries to sell back the energy to the grid. That's something we have started to explore with the distribution network. We found that it's possible to gather the data, although it's very difficult to gather data at the household level. So we managed to discuss types of aggregated data that can help to model the problem of selling back energy to the grid, and even handling changing tariffs. But we are in the process of discussing this with distribution network, and it's something definitely we want to put in the roadmap during the next 9 months and explore more.
Brilliant, thank you. So we've had another question. How are you managing data quality and its impact on the modelling?
Maybe I can ask Rob to pick this if
yes, it's a good question, really, because I think so going back to what I was saying before, because this sector, this data sector, is so new, the energy, so the data quality is really quite variable, and so it's something that's at the center of what we're thinking in our models that we're using, and also how we're presenting that information to users. So from a modeling perspective, one of the key technologies we use is Gaussian processors, which actually incorporate poor data quality and handle it, and is aware of poor data quality. But also we think that the other way to manage it is really transparency, is to make sure that users are aware that data quality might not be very good. And to a certain extent, we can identify that, but also the onus is somewhat on users, because they know their data best. Someone in Oxfordshire County Council, for instance, knows their towns, their streets better than we can know them. So it's providing them the tools to understand and reliably and safely interpret their data, regardless of the quality.
Great, thank you. And then finally, just to wrap up our last question of the session, what are the top 3 data sets you'd like to search, and do you know where they are located?
Yes, I have an answer to this question. Might be more than 3. So definitely, we would like more accurate capacity data from the network, from the distribution network. We know that distribution network have done huge effort in providing those data, and there is more open source data available as well. What would be ideal is to have this data to be consistent across the nation. So one of the problems is that maybe one local authority is happening to sit across 2 or even 3 distribution networks. Integrating data might be quite a challenge, and also communication, etc. So one would be, I would say, a consistent is really important way to gather data about capacity across the network. Another one would be more accurate EV registration data. There's some issues with the EV registration, partly because of the way the system record them, especially if there is an issue with leased electric vehicles that was highlighted during the project by other project partners and by some of the projects that have presented as well here at MEDAPS. So this would be also something I would like to see. And the third one, really tricky. It's more about smart meters and local household data. So there is a very important issue about the ethics and the privacy of handling smart meter local housing data. And we know that it's not possible to have access to really detailed individual household for privacy reason. But it would be nice to see a joint effort in trying to define governance and strategy to gather this data and make them usable, because the sector will really benefit. This obviously not at the expenses of the users and their privacy and their rights. So that's maybe a bit more of a data governance challenge rather than a data availability challenge that I'm expressing here. And all this nationwide.
Yeah, definitely. Brilliant. Well, thank you very much for your presentation today and answering all of the questions. We're now going to take a short break and reconvene in about 5 minutes for DNB to take over with their presentation. So thank you, Alessandra and the team. Really interesting. Thanks.